Okay, in this video we're going to start solving by substitution. Now I have the steps written over here on the right, so if you need to take a minute and pause the video to copy them down, go ahead and do so. The steps are, the first step is solve one equation for one variable. Then the second step is to substitute the expression you found in step 1 into the other equation and solve for the remaining variable. Step 3 is to substitute the solution from the first variable that you found to find the second variable. And then the last step is to check your answer to see if it works in both equations. So let's go ahead and do this. I'm going to call this equation 1 and this equation 2. So I'm going to pick a variable in one of the equations. It truly does not matter which variable and which equation that you pick. I can tell you with experience after you get better at this, sometimes you can recognize that solving for one might be easier than the other, but you're still going to come out with the same answer no matter what variable you start with. So I'm going to choose this x. I'm going to pick the first equation and solve for x. So now I'm just working in step 1. I'm going to pick one equation and solve for one variable. So I'm going to isolate that x by adding 3y to both sides. And then divide both sides by 2. So now I have an expression for x in terms of y. So I'm going to take this expression that I found for x, now this is going to be in step 2, and I'm going to substitute that expression into the second equation. So this right here is going to go in for my x in the second equation. So now I'm going to have, I'll do this one in blue since this is the second equation, 3. And then I'm going to substitute in from the first equation, 3y plus 11 over 2 minus 2y is equal to 9. Now I have everything in terms of y, and I can solve for y. So I'm going to distribute that 3. So that gives me 9y plus 33 all over 2 minus 2y is equal to 9. Now I'm going to clear the fractions by multiplying everything by 2. When I multiply the first term by 2, I'm just going to end up with 9y plus 33. Then when I multiply the negative 2y by 2, that's going to give me a minus 4y. 9 by 2 will give me 18. So now I have a 9y and a minus 4y. That gives me a 5y plus 33 is equal to 18. So then I'm going to continue to solve for y, and I'm going to take and subtract 33 from both sides. So I have 5y is equal to negative 15, which gives me that y is negative 3. So I found my value of y. So that was step 2. I substitute my expression back into the second equation to solve for the remaining variable. In this case, my remaining variable was y. In the third step, it says now substitute the solution from the first variable that you found to find the second variable. So now we're going to take the y and plug it back in to find x. Now you can plug it back in anywhere you want to find x. But I can tell you from experience that it's easiest to plug it back in here from where you originally solved for x. That's the easiest way to do it, but you can plug it in anywhere. So I'm going to take negative 3 and plug it in for y. So I have 3 times negative 3 plus 11 all over 2. So when I take negative 3 times 3, that gives me a negative 9. A negative 9 plus 11, positive 2. And then I take 2 divided by 2, and I get 1. So my answer is going to be 1 for x, and y is negative 3. And then to continue to step 4, I would just plug in x is 1 and y is negative 3 into both of those equations to make sure it works for both of them. The other thing that you can do to check your answer is to graph both of those lines and make sure that they intersect at the point 1 for x and y for negative 3. The only downfall with that is when you check it on your calculator using the graphing method, you have to make sure when you plug it into your calculator, it's in y equals mx plus b form. So since these are not in y equals mx plus b form, you have to do a little bit of work first. For example 2, I am going to solve, I'm going to do the same steps. I'm going to solve equation 1 for x. So I'm going to solve for this x right here. So I'm going to add 4y to both sides. And then I'm going to divide by negative 2. So I have x is equal to 0.6 minus 2y. And that's a positive 0.6 because I have a negative divided by a negative. Okay, so this is going to be my expression that I'm going to plug in now to my second equation. So my second equation is minus 5, and then I'm going to put in for x my 0.6 minus 2y plus 3y is equal to negative 1.7. And now I have everything in terms of y, and I can solve for y. So I have to take the negative 5 times the 0.6. That will give me a negative 3. Then the negative 5 times the negative 2y gives me a positive 10y. And I have a plus 3y is equal to negative 1.7. I can combine the 10y and the 3y to give me 13y. So I have minus 3 plus 13y is equal to negative 1.7. Then I'm going to add 3 to both sides. That's going to give me a 1.3. And then when I divide both sides by y is 0.1. So I've got my y value, and now I'm going to plug my y value back in over here to find x. Since I know x is 0.6 minus 2 times y, if I just plug in the 0.1 there for the y, I'll get my value of x. So I have 0.6 minus 2 times 0.1. That's going to give me an x that is 0.4. If I write my answer as an ordered pair, it would be 0.4 comma 0.1 because I put my x and then my y. And then of course, if you want to check it, you plug it back into both equations to make sure it works for both, or you can check it on your calculator by graphing both of those lines and making sure that they intersect at the point 0.4, 0.1.